necessarily on the points that are created. We actually won't even need any of those points, so you'll just need to be able to snip the graph so you can see what it looks like. And then we're going to do some analysis that are specific more towards the trig stuff. What I have on this first page, though, it's not that these graphs don't have some of these things we've talked about in the past. They do. We just mostly focus on the trig-based stuff because we've done most of this stuff with enough other graphs that we don't necessarily need to focus on it in these graphs because we've got other stuff going on. So this first slide, we're just going to focus on sine and cosine to start with. We're going to eventually graph all 6 functions. The nice thing is the Desmos has all 6 programmed in, so you can just type them all in as is, and it should be able to graph it just fine. It also has pi programmed in, because a lot of our equations will have pi in it, because it's a common value that we put in sine or cosine. So again, the Desmos is programmed ready for you to use. Okay. So then with these, this is kind of running through some of those things we talked about back in chapter 1 about a specific sine graph. Again, it has y-intercepts. There's just one. Typically, it's at 0 to start with. But again, as we move this graph around, up, down, around, the y-axis might change a little bit. It does have x-intercepts. This is kind of one of the reasons why we don't end up doing this a lot, because these things are called oscillating functions, which means they're going to go back and forth forever and ever in both directions. So it will actually have an infinite number of zeros or x-intercepts. So that's what makes it hard to analyze x-intercepts for these graphs. Typically, it starts off every pi, is what the common interval is. But again, as you shift the graph left and right, that'll change slightly. But again, that's where it starts off with plain sine of x, because that's our parent function. Throwing back that word. Again, if it's just sine of x, this is what that graph looks like. And then again, as you put numbers in and around sine, again, I'll adjust it a little bit. It's odd function because again it's symmetric about the origin. So remember what that is. If you look up in quadrant 1 and look down in quadrant 2, they're the same. So they're symmetric about the origin, which is also called odd. And there's a ton of minimums and maximums because again this is going to oscillate. So there's a bunch of different extrema, which again makes it hard to analyze the extrema because there's infinite number of extrema in both directions. So that's why we really can't do that. But again, it does have minimums and maximums, and they usually are at intervals. So like this one, it goes up as high as 1 and down as low as -1 every single time. So it's going to oscillate between those two functions. I don't know what oscillate means. I don't know. So have you ever seen a fan where it goes this way and then it bounces back?
It's a repeated motion.
Oscillating, that's a repeated motion. So it just kind of bounces back and forth. So it's never going to go higher than 1 or lower than -1. And it's just going to continue to make that curve. So that's what the oscillating function is. Okay. And so because it's oscillating and it repeats itself, one big thing that we're focused on is something called the period. The period of just plain parent function for sine of x is 2 pi. And what that means is that's how long it takes for it to repeat itself. So if we start here at 0, the graph goes up, turns, goes back down, hits -1, turns, and goes back up. And then now it's at that same spot it was at 0, 0 over here. And it's going to repeat that same motion. So a period is basically how long does it take to repeat itself. So, like I said, these are very cyclical graphs because they just continue to repeat the same type of curve on and on and on. So one thing we'll really focus on is the period, because as we put numbers in and around sine, that's going to adjust how quickly it will repeat itself. So period is one big thing that we'll work with. Like I said, the main period starts out as 2 pi, but again, that'll adjust depending on what numbers we put in and around sine. So then the bottom half, that's just going to be the same type of thing with cosine. If you notice, they look pretty similar if you're just looking at it as a wide picture. But again, it does start in a couple of different spots. Sine started at 0, 0. This one, if you think of this as the starting point, it starts up here at 1. But then again, it bounces back and forth between 1 and -1. Again, that just means cosine's just adjusted a little bit. It's more based off of the x values and the y values like sine. Its intercepts are at pi over 2, so it's every half pi instead of pi. Again, this one, if you look at it, it's actually symmetric about the y-axis. Because if you fold it over the y-axis, it folds on top of itself. So it's a little bit different symmetry. And like I said, the minimums and maximums, that's where it's always going to occur. It's always going to bounce between 1 and -1. Now, like I said, we can adjust that. So sometimes your graph, as you put numbers in and around cosine, that might actually shoot the graph up a little bit higher than what it started off to be. But again, this is all based off the parity function. And again, it repeats itself every 2 pi. So if you just look at this one, so if you just zoom in on the shape, it actually is a little bit different. So it kind of looks like a big swoop and then back up and it repeats itself. Okay. So like I said, I just wanted to talk a little bit about some of the properties of the graph, kind of tie it back into different things we've done with the graphs in the past. But really our analysis for trig graphs are a little bit different than any of the other graphs we've done. So on the next page, what I like about these pictures is because, like I said, if you look out at sine and cosine, the graphs look pretty much the same. But if you just look at one single period of each, they're actually kind of a different shape. Okay, so one period means this is just one part of the curve before it repeats itself. So sine, if you think about it starting at 0, 0, it'll go up to 1, then cross down, its x-intercept is at pi, and then it goes down to -1, and then goes back up to 2 pi. Okay, so that's one period of sine. One period of cosine, actually, if you look at it, it looks kind of like a parabola a little bit. It starts at 1, swoops down, goes through its x-intercept at pi over 2, goes down to -1, comes back up, another half pi, which is 1 1/2 pi, and then back up to positive pi. Now, the reason why this is important, what you're going to have to do is I want a specific snip. So whenever you're snipping the graph, because sometimes that repeats a lot, and you see a lot of these curves because it repeats faster than 2 pi, or it might take a little longer, so it might take 4 pi's to repeat itself. When you snip it, I do want a specific snip. So what I usually have you do is snip me 2 periods of each graph. Okay, so basically if you're looking at sine, I want 2 of these in your snip. Okay, so like I said, with your snip, you have to be specific. So that's why on this slide I showed you what one period looks like. So then in your snip, you can get 2 of these for sine. And then for cosine, this is what one period would look like. And so then in your snip, I would just want a second one. So I don't want a ton of these, because like I said, sometimes our graph repeats itself very quickly, and it looks all crazy. And I'll show you some that look like that. So in your snips, you will be specific. I want 2 periods of each in your snip. Okay. So now we're going to talk about some of the analysis, and then some of the definitions. I did leave blanks for you to fill in, so do make sure you fill in the definitions of how we get these next things we're going to analyze. So there's 5 things we're going to list about the graph, and a lot of it we can actually get from the equation, because the equation, what we put in and around sine and cosine, really does affect our graph. Okay. So there's 4 places you can put numbers in and around your sine and cosine. An a value is in front of the sign that's being multiplied in front of sine or cosine, so the a is in the same spot. We can have a b value that's being multiplied to x inside the sine or cosine. We can have a number that's added or subtracted behind the x but still inside of the trig function, so it's the c. And then we can have a number that's added outside the function, which is the b. So there's 4 different places I can put numbers. And those 4 things will help us with our analysis. Like I said, there's actually 5 things that we list about the graph, and a lot of it will come from the equation. First thing is amplitude. Amplitude is half the distance between the minimum and maximum value. Essentially, it's the height of the graph. So the basic amplitude of your graph is 1, because it bounces back and forth between 1 and -1. But as you change the amplitude, that will change the height. So you might make your amplitude 2, so that way it'll bounce back between 2 and -2. Or you could make your amplitude half, so it wouldn't go up quite as high, so it just bounce back and forth between half and -half. And there's really only one thing that affects amplitude, okay? And you can actually just look at it. So you can kind of see it from the graph, but you can actually see what the amplitude is going to be by looking at one single number in the equation. And that is the A value. So whatever number you multiply in front of the sine or cosine, that's going to affect the height. So since there's no number in the original parent function, it's just sine of x. It's like 1. Our height was 1 and negative 1. Okay? But if we do 2 sine, it'll go up to 2, down to negative 2. So as you adjust just this number in the equation, the A value, that changes how high the graph goes. Okay. So like I said, you can see it from the graph, but you can actually pick it out of the equation, so you can see what your height should be just by looking at the number that you have in front of your sine and cosine. So that's one thing you're going to analyze. So I'll ask you what the amplitude is, and like I said, you can just look at the equation, whatever that A value is, that's your amplitude. Period, I talked about this a little bit, but I wanted to put the formal definition in there. So it's the distance between repeating points. So it's how long it takes to repeat itself. So usually, on a typical sine graph with no numbers in it, it takes 2 pi or about 6 units before it can repeat itself. Okay? Now we can adjust that, and actually there's one number that you can use to help adjust your period. But like I said, the basic period is 2 pi, and then we adjust based off of one number that we adjust in the equation. That's actually the B value. So whatever the B value is will affect the period. What? That looks completely.
Is the absolute value of B?
Yeah, I'll take it off because B is never negative. So let's take that off. Let's just do 2 pi over B. Very rarely negative. So officially it's the absolute value because if the B is negative, you just take it off and divide by the positive number. But like I said, B is very rarely negative, so it's easier just to think of it as 2 pi over B. So like I said, where we get the 2 pi is that's the initial period of the sine function. So the parent function of sine, it takes 2 pi's for it to repeat itself. So if you wanted to repeat quicker or slower, all you need to do in the equation is adjust this number. Okay, just the B value. So whatever that number is, you'll divide the 2 pi by it. So if it's a bigger number, that means it's going to repeat quicker. Because if you're originally 6 units, and then you're dividing it in half, that means it's going to repeat every 3 units instead. Because usually it's 2 pi. We talk about how 2 pi is like 6 point whatever. So again, if you divide it in half, it's only going to repeat every pi. So if you make that B value bigger, it's going to repeat faster. If you make that B number smaller, like a half or a third or something like that, it's going to take a lot longer for it to repeat. Okay? So again, you can adjust the period just by adjusting one number in the equation, and that's the B value. And then once you have the period, the frequency is really easy because the frequency is the number of cycles completed in 1 unit, which is just the reciprocal of the period. I have what the frequency is, but like, so once you have the period, so say your period's 2 pi over 3, okay, the frequency would be 3 over 2 pi. And that would be what your frequency is. So once you find your period, the frequency is just really easy, just flip it. And for some reason, since we've done all this stuff with square roots, people are curious about having pi in the bottom of a fraction. That's fine, pi is just a number. It's just square roots that we can't have down there. So again, like I said, if your period was 2 pi over 6, well, how do we simplify? 2 pi over 5, your frequency would be 5 over 2 pi. If it'd be 1 over 2 pi. So again, if it's just a single number of pi, it just put 1 over it. If it's a fraction, go ahead and flip it. Pick the absolute value part. That's faster than we do. Like I said, that's officially what it is, but like I said, just remember that's reciprocal of the period, so whatever you get for the period, flip it, and that's your frequency. There's the kind of graph that's drawing it. So how many cycles you get in 1 unit? Phase shift is another thing that we can look at with the graph. We used to call this just a horizontal shift, but in trig, since the whole graph's going to shift forever, because it's an infinite graph that continues on and on and on in the same pattern forever and ever, they call it phase shift. So it's a difference in a horizontal position. So basically, it's how far it moves left and right, but instead of calling it a horizontal shift, we call it a phase shift. And this is actually affected by 2 things in the equation. It's actually everything that's inside of the sine or cosine. And there's 2 things that are inside the sine and cosine, which are C and B. So B affects the period. It also affects phase shift. And like I said, you can kind of see this all from the graph. But the nice thing is, if we know a little bit of how the numbers are affecting our graph, we can actually use the equation to help us more define it than try to estimate it from the graph. So to get phase shift, okay, it is opposite of C over B. So I just put a little negative in front of C, so it's opposite of C over B. So if C happens to be positive, its phase shift would be negative, okay? If the C was already negative, its phase shift would be positive. So it's opposite of the C value divided by the B value. And again, it just takes it and shifts the graph to the left or the right.
Are you scribbling out the ones you typed because it looks like it's absolute value?
Yeah, it's technically supposed to be absolute value, but B value is very rarely negative. So that just trips people up. So just and I was trying to retype it, but that took longer than scribbling. Okay. Last thing. So typically the midline is right down the x-axis. Okay. If you look at all my little pictures, all my little snips that goes with all the little things we'll analyze about the graph, is all down the x-axis. Now every once in a while though, we can take our graph and shift it vertically. So we basically change the midline of the graph. So instead of just bouncing back over the x-axis, it bounces over this midline, which is actually just whatever the D value is. Because if you remember back when I was writing, when I had those things typed, so we had A sine of bx plus c, and then outside was the plus d, that actually just makes it like a vertical shift. So instead of calling it midline, we'll just call it vertical shift. But again, that is what happens when you shift a trig function vertically, is it changes the middle of the graph. So instead of necessarily bouncing around the x-axis, like most graphs will, that'll now be the middle of the graph. And then this graph kind of shows, so now instead of having the midline where the graph's down the middle of the x-axis, this is now shifted up to 2, so that's now the middle. So then the amplitude is above and below that. Phase shift shifts off the x-axis. Vertical shift is what's shifting that. Okay, so we're going to snip a graph, 2 periods specifically. If you get a little bit extra, that's okay. I would rather have a little extra than not enough. But I don't want a huge snip of just a bunch of little curves. Okay, so I am going to look for some specific snips, which I'll talk about that in a second. And then we're going to list the amplitude, the period, the frequency, the phase shift, and the vertical shift of each graph. Okay. So I have them all defined, so let's actually work through and find all this stuff from the graph. I have all the things pre-snipped on your note packet, so that way you have that. But notice I didn't highlight any points because we're not worried about extrema, we're not worried about intercept, we're just worried about these specific things for this trig graph. Okay. So I probably won't snip or go through each one of these, but I will at least talk about how I got this graph and how I got this specific snip that I want you to have. So again, Desmos, same graphing program we've always used. You can actually just type in the word SIN for sine, and it'll know what that is. You don't even need the y equals part, so I'm going to start typing with the 2. So it's 2, and then I can just type the letters SIN, and it'll recognize that. Then a parenthesis, and 5x plus. Okay, then here's where it gets kind of interesting. To get pi, there's 2 ways to do it. There is a key underneath the online keyboard. If you go down here, it's down here at the bottom, there's your pi, so you can click that. Or if you just type the word pi and spell it correctly, it'll translate it to the pi symbol, okay?
Yeah.
So pi, that's the dessert.
PI.
It's just pi. Yep. So the dessert is PIE, and so don't type that in because then remember E's a thing. So if you accidentally type PIE, it'll throw an E in there and throw the whole thing off. So if you type it PI, it switches it to a pi. Okay. So again, you have to spell it right. So pi is PI. Again, if you type an E, that'll completely kind of mess it up. Didn't like throw it off completely, but it messes it up. So then to get the division, just hit divide, and it'll put it right underneath the pi, and put the 4. Then make sure you arrow out. Actually, there's nothing else left. But if you did have a vertical shift on this one, just make sure you arrow out, because once you create a fraction, the cursor stays down there until you hit the right arrow, and then you can arrow out, and then this is what our graph looks like. So notice this is not what my snip looks like, because this graph, because we have a b value and a kind of a bigger b value, it actually takes less time for it to repeat itself, so it's going a lot quicker. So I don't want to see snips like this here, so I'm looking for a specific snip where I can get 2 periods. So I'm going to zoom in a little bit, maybe a little bit. So in order to get 2 nice snips of sine, I just pick a point to start with. So I'm going to pick this one. And again, you don't have to highlight any points because I'm not worried about the x-intercepts, I'm not worried about the y-intercepts, minimums and maximums, because there's way too many of those to really worry about. So I'm just going to pick a point here. So if I go up, down, and back, that's 1 period of sine. And then I go up, down, and back, that's 2 periods. So in my snip, I'm just going to get 2 periods of that sine curve. So here's where I was starting. So I'm going to make sure I get that here. And then up, down, and back, there's 1 period. Up, down, and back, there's 2. And so that's 2 periods of that sine curve. So again, pick a point to start. So I got up, down, and back, up, down, and back. So I got a little bit extra on each side, but that's okay. It's okay to have just a little bit extra, but I don't want all of those curves because I just want 2 periods. That's how I got that snip. Any questions on the snip part? Actually, the nice thing is you don't have to highlight anything. So there is the snip of 2 periods. I actually put that last, but I want to talk about it first. So now we're going to state the amplitude. Amplitude is what?
2.
Yep, 2. Yep, it's the A value. And remember, it goes A, B, C, D. So the amplitude is just 2. And like I said, you can kind of see that here. Notice how the height has now changed. Instead of 1 and -1, it's going up to 2, down to -2. So the height has changed. Period. It's 2 pi over b. Now you don't have to write 2 pi over b each time, but I'm just doing a quick reminder. So 2 pi is the initial starting period, and then as we change the b value in the equation, that changes the period. So what's the b value? 5. Yeah, so this period is going to be 2 pi over 5. Frequency, I abbreviate to that. So frequency, remember, is just the reciprocal of the period. So I know I have a couple of ways to find it on your sheet, but again, once you have your period, it's the reciprocal of that. So the frequency is going to be 5 over 2 pi. So amplitude's 2, period's 2 pi over 5, frequency's 5 over 2 pi. So once you have your period, just flip it, there's your frequency. Phase shift. Okay, this one is opposite of C over B. So this is the one you might have to do a little bit of work with, because I want you to simplify when you can. So up to this point, we really haven't been able to simplify. Like this one, if it was 2 pi over 4, I want you to simplify that. Okay. Same thing would be similar here. But again, if you have some numbers you can simplify, do it. We haven't had to worry about that so far here, but we will have to do that with the phase shift. Okay, so the C value is this fraction pi over 4. Now we do the opposite of it, so since it's plus pi over 4, we're going to use negative pi over 4. So that's our C value. And again, it's opposite of what it starts off to be. So since it was positive pi over 4, it's negative pi over 4. Everyone good with that? And then we put it over the b. Okay, we're not going to leave fractions over fractions. So we're always going to simplify these. So if you see a fraction over a fraction, even though it looks like fraction over a single number, there's always a way we can fix it. Do you remember how you divide the fractions? Multiply by the reciprocal of the bottom. So what I like to do is make everything look like a fraction so that I don't do this incorrect. Okay? Because I have a lot of people that will have something divided by 5 and then actually multiply it by 5, which dividing something by 5 and multiplying it by 5 are not the same thing. So really what we're doing is dividing it by 5 over 1. So how we simplify this is you take the top fraction and you take it times the reciprocal of the bottom fraction. So the negative pi over 4 does not change. But what we're going to, instead of dividing it by 5 over 1, we're going to multiply it by, what's the reciprocal of 5 over 1? 1 over 5. Okay. And now we're just multiplying with the fraction. So we multiply with the fraction just straight across. So take negative pi times 1.
In other words, don't you just take, you're just going to multiply whatever's below that with the denominator.
But it's just the same amount. If it's another fraction. Okay. So again, multiply by the reciprocal of the bottom. Again, make sure it's everything's a fraction, because like I said, it sounds silly, but a lot of people see 5 and they forget they need to take the reciprocal of it. So I have a lot of people that are dividing by 5 and accidentally multiply by 5. So always multiply by the reciprocal. So if it's 5, its reciprocal is 1/5, and then just multiply straight across. So that's its phase shift. Okay, and then the vertical shift. Where do we get the vertical shift? What's the vertical shift?
We don't have one.
We don't have one. Why not?
No D.
There's no D value. Okay? So there's nothing added behind it, but I do want you to include it so there's no D value too.
Can I do like PS and BS?
Yes. I will from here on out, but for this first example, I won't do that. Except for frequency. I don't know why I don't do that. Or amplitude. I don't know why I did some of I don't know.
You
Yes,
like
you
to
can
write
abbreviate on it.
period, and that's it.
Yep. Question about the first one.
I mean, there's a difference between a 6-letter word and 9, 10-letter word.
Yes. Alright, let's look at the next one. Where do you want to try to count the letters?
Yeah.
Alright, now you are going to have to zoom when you use the graphing calculator. So, in between each graphs, I would highly suggest going over here and clicking the home button, before you type in the next graph, because we had to zoom in quite a bit for that graph. And so if you don't do that, you're going to have, your zooms might be a little off and your graphs might affect you a little bit. So in between each graph, I would suggest going over there and clicking the home button. And so now I'm going to type my next graph, which is, okay, there's no a value, so I'll just start with the cosine. So it's cosine of x over 2. So I can do x, and then hit my divide key, 2. And then like I said, the cursor is going to stay in the denominator, so make sure you hit the right arrow to get it out. And then plus, and then I like to just spell out pi, and then divide by 4. And then again, hit arrow out, close the parenthesis, make sure you close that parenthesis, type it as you see it, and then plus 2. Okay. So in order to get 2 periods of cosine, there's actually not 2 periods up there right now. So again, pick a starting point. So I'll pick one up here, or you can do here. I'll see here. So this one goes down, and then it doesn't even go all the way back up here. If I picked here, here's 1 period, but I don't have another one. So I am going to have to zoom out a little bit to get a second period for cosine. So then, like I said, just pick a starting spot and just make sure you get 2 curves of it. So if I pick this one, it goes down, back up, so there's 1. It goes down, and back up, there's 2. So I'm going to snip this whole chunk of the graph so I can get 2 periods of the function. Which I did. Okay, so that's where you can see 2 periods of that function. Again, down, up, 2 periods. Okay. I always want you to list everything. So what's our amplitude? 1. Yep. Because if we don't have a number in front of cosine, it's like a 1. It can't be 0 because then the whole thing would be 0. Alright. Period is 2 pi over b. Here's where it gets a little bit interesting. What's the b value? It's a fraction. Yep. Now, when you do the b value, we don't need the x. So when we have x over 2, what would the b value be for that?
1
Just 1?
over 2.
Over 2. Yep. So when you see something like this where it's x over 2 or x over 4 or x over 5, you get that sometimes. When you see that, the b value, we're just going to use it as 1 over 2 because in the period, we don't need the x. So if you take the x out, there needs to be something there. So we make it 1 over 2. Okay. Now again, this one I'll have to simplify because again, I don't like to see a fraction with a fraction. So how do we divide with fractions? Multiply that by the reciprocal of the bottom. So if it helps you, you can make everything a fraction. Or you don't have to do that. But again, we have to take the top times the reciprocal of the bottom. So the top is just the 2 pi over 1. And then we have to take the take it times the reciprocal of the bottom. So what's the reciprocal of 1 over 2? 2 over 1. So I multiply straight across. Would I have to put it over 1? No, so I'm just going to say it's 4 pi. So our initial period was 2 pi. This one's now 4 pi. So if you notice, that's why I had to zoom out because it takes a lot longer for it to repeat. So I had to actually zoom out so I could get 2 periods. Okay, frequency is just the reciprocal of that. So if our period is 4 pi, what's the reciprocal of that? 1 over 4 pi. Phase shift is opposite of c over b. Okay, a lot of times c ends up being positive originally, so my phase shift is going to be negative. Over my b value, which we talked about, b value is 1/2. You're going to get really good at dividing with fractions. How do I divide with fractions? Multiply by the reciprocal. Okay, so we multiply straight across, so I'm negative 2 over 5. Negative 2 pi over 4. You think I'm going to leave it like that? No. What can I do to simplify it further? Okay. Now I will say, not all of them are ugly fractions. fractions, the reason I picked these specific examples is so we could go through some of the uglier fractions together. So we have amplitude, period, frequency, phase shift, and then vertical shift, which is here's one.
Yeah, I went to 2 minutes yesterday. Why did you cry?
Okay. Any questions on those first two examples? Okay. We may do the last two examples together tomorrow, but we're kind of running short on time, so we're gonna stop there for today. And I'm gonna post your assignment. Like I said, specific snip. I'm gonna be looking for that specific snip. If you give me too much or too little, I'll take off points. Okay. Amplitude, period, frequency, phase shift. Now, like I said, I picked these two examples specifically because there's a lot of fractions. Not every single one will have fractions, so don't think that. But I wanted to make sure we went through that part together because I know how everybody feels about fractions. So I'm going to post that assignment now, which we'll have time to work on it tomorrow as well.
We only have 8 minutes, so.
It's just like giving us worksheets with an impossible deadline to get done.
At least we have.
How many are there? Oh no.
6. And then there's a multiple choice.
And you're gonna pull off
Multiple choices. My
7 of
weakness.
those.
I'm gonna forget.
Alright, so my
too,
my
but
classroom
you
is
have
pretty
to
slow,
have
so
some
we're gonna post it. Yeah, but this is what the assignment will look like as soon as I get it posted.
I'm gonna print mine.
Let me guess, we don't have to do the even numbers.
What?
I have to do all 6. It's just 6.
Nice try, Bree.
But didn't you just say seven
Well,
was multiple
The
choice?
7th one is just multiple choice. Use a graph.
That's
figure out
still
which
technically
equation it is
7
from.
probably. I mean, I could be counting wrong, but.
You know a little bit about amplitude, you might be able to figure out that graph.
No, I don't know anything about it. Spoiler alert.
Max,
Did you just give us the answer? You're lying. It's never C. It is.
Oh,
So we use it in year. I don't even know how that
Let's see.
it could even work.
Oh my gosh. Oh, speaking of, I was just gonna say, did you get A and C? Like,
Math,
I got
Yes,
so many
okay.
A's.
Yeah, me too.
Well, when there's only 3 options.
Yeah.
But I mean, it'd be like a But then, like, the last
Well,
one.
what was the
Sorry.
actual?
that's why I want a specific snitch and then we can get all the answers.
Well, that's a good thing I didn't put any D's because I was not paying attention and I didn't know what she said. So I almost put a couple of them. Like, what? When did that happen?
Hey, do you have any cherry jam
When
or
did that happen?
honey cherries, berry juice? Or
I'm-
I